Hey, what's up guys? Mario here. So, I know I haven't been able to put that much time into building my own CNC, and it's actually taking me a little longer than what I was expecting. But I made a couple pieces so I can continue building the CNC. In case you guys didn't see, part 1 was where I actually built the frame using the Aluminium Extrusions from 8020 ink. All I needed to do was select the profile, select the length, and when I received all the pieces, all the measurements were exactly as I ordered it. That saved me, a little more time trying to cut all the aluminum extrusions myself and try to get all the measurements right. So here's the first piece I needed to make, and it's just like a little spacer for the ball screw. So the shaft of the ball screw and the shaft of the Technic servo motor will be aligned. After I got that, I mounted it to the bottom of the frame, and I started taking some measurements to make the two pieces that will go right here on the side. So here's the pieces. That one will go on that side and this one will go on this side. But when I was cutting these pieces, I guess I was rushing, like I said, I didn't have that much time. I guess I was rushing and I didn't pay attention, and it was like a mistake I made. But I ended up making, let's say, 2 of the same size. So the counter holes on this side, they needed to be on this side. So all I needed to do to fix it was to make new counter holes on this side. This piece will still work, for what I need. So here I have the 25mm linear rail and the bearing block from Staf. And I got all these pieces from a company called Tech. The one thing I really like, or the couple things I really like about these bearing blocks, is that it has 4 rows of bearings, so they can be mounted on any position and they can support the weight in any direction, either from all the way from the top or from either side, or even if you try to pull it. The other thing is that there is no slack at all. There is no movement, no wiggles or nothing really. They roll really smooth. They have a little resistance, so it's not like I can just go like this and it will just slide off. And that resistance is because, they're really high precision bearing blocks. So that, that doesn't give you any, slack or wiggliness, on the bearings. But I did notice one thing, that when I was attaching, testing to see if all these pieces will actually fit, I noticed that when I was attaching this piece that will actually go on into the other side, as soon as I tighten all the screws, I can feel a rough, like a rough slide. It wouldn't roll smooth. It will almost grind, let's say. But as soon as I loosen, some of the screws and just, hand tight, it will roll really smooth. So at first I thought it was maybe the screws were a little too long. So I got different screws. I put, shorter screw, and still will do the same. So then I changed the bearings, the bearing blocks for a different set, and it will still do the same. I then change the linear rail for a different one, and it will actually still do the same. So after a while, I was looking at the aluminum, and even though the aluminum, it's really flat. I mean, just with a night, by eyesight, you cannot really notice nothing. So when I was just checking this, I got a ruler and I put it from, like this, from side to side, and I slide it, back and forward. And when I did that, it actually on here on the side, it left some like scratching, like telling me that here was like a high point. So I sanded the aluminum down a little bit to make everything, really flat. And as soon as I did that, I mean, all the bearings, you can feel the whole piece just go back and forward really smooth. So that's one thing I have learned, that when trying to build the high precision CNC, it does require to have, let's say, high precision parts with tight tolerance. You can have something, uneven, like I said, like something with high spots and low spots, then like, let's say, like these sets of bearings, they don't like to be one higher than the other one. They, the bearings will actually start to bind. So that's, one thing I have learned when using high precision parts instead of something that has a little more play. So right now what I'm about to do is just get the screws mounted to the bearings, then mounted to the gantry, and then mount the bottom piece that will be attached to the ball screw. That will make the whole axis go back and forward. In case you guys are wondering where I got all the screws that I'm using to build the CNC, and I got them from a McMaster car. They have every single screw I needed, all sizes, different kind of screw, either a hex or a Phillips or a flat. They got it all, really. So that's what I'm about to do right now. So before I connect the bottom piece that's gonna be attached to the ball screw, I wanted to show you how it actually moves back and forward. It rolls really smooth. There is actually no binding. If I push it with my hand, it will travel some distance and then it will stop. And that's because the resistance that the bearing blocks has. But overall, no binding from all the way from the front to all the way to the back. All I need to do now is just mount the linear rail right here at the top, the other one right here at the bottom, and the ball screw right here at the back. And then I can start taking some measurements so I can start building my Z-axis. Hopefully some of the tips I gave you, or maybe some of the things I show you, help you if you're making your own CNC or if you're planning to build one. If you like the video, don't forget to like, share, and subscribe. You can follow me on Twitter and Instagram, or you can leave me a comment below if you have any questions about this video. Thank you for watching, and I'll see you next time.